Okay, so what you have on your desk in front of you is your final assessment of vector component addition. And it goes from like very, very basic to more complex, and then kind of finishes off with some bulk questions. Okay, but it seems like we're pretty proficient at this, so none of these should be particularly challenging for you. Okay, what I'm going to do is just kind of give you a couple of tips and hints for particular questions, just for things to watch out for. Question number 1, super, super easy. Don't overthink it, would be my tip for question number 1. You have two vectors that are pointing in exactly the same direction. Okay, but there is one small thing to watch for here, and it is a rule to do with significant digits. Okay, remember that with significant digits, any numbers that are used to calculate your final answer contribute to your final answer. However, in this question, there may be two different numbers of significant digits. One for the magnitude and one for the vector. Because after all, these point in exactly the same direction. Okay, so it's actually possible to have the magnitude have one set of significant digits and the vector to have a different set of significant digits because you're not using them to calculate each other. Okay, it's a weird, rare situation. Okay, question number 2. People get confused with this one because of the context of the question. All right, remember that any vector quantity, displacement, velocity, acceleration, or in this case, force, all vector quantities are added in the same way. That is, they are drawn tail to head. Okay? But what often happens with this question is people picture it in their minds, which is actually a good thing, but they draw it the way it looks in reality. And that is that you have an object that is being pulled in two different directions. That's what's happening. Is that how I should draw it? No, because if I draw it that way, it's going to say it's going this way. The last time I checked, pulling up and to the right does not make something go down and to the left. Or down and to the right. But either way, okay? Make sure you're still drawing this tail to head, because if you do, it will actually go in the direction it's supposed to go. Okay. Question number 3, don't overthink that one as well. Okay, that one's pretty straightforward, very much like what you would get on an exam. We've done a ton of questions like number 3. Okay. Question number 4 is simply asking you to calculate the vector components. So it's saying, here's a single vector, find x and find y. Big thing here, look at the vector that the question gives you. Make sure the vectors you give for the x and y components match that. Okay? You can't magically come up with like east and west on this because that's not what the question gives you. All right? So it's talking about an x, y plot. Okay? Where this is the positive y, this is the positive x, this is the negative y, and this is the negative x axis. Okay, that's what it's talking about. So when you're drawing it out, that's probably what you should start with. Okay. Question number 5, same deal. It just wants you to find the x and y components, but this time it does give you compass directions, so compass directions would be appropriate to use in your answer. Question number 6, simple vector addition question, very much like what you would get on an exam. Okay, one that's straight. Okay, and one that is angled, but watch this part. It is saying that only one of the two possible vectors, the complementary angles, will be correct. It wants the direction relative to due east. So something of east, north or south of east. Okay, that's the one it's looking for. That's the one that would be correct in this case. For number 7, it's just a vector addition question. It just has 3 vectors. Okay, but 2 of them are straight, okay, like one's east and one's north, and only one of them is angled. So it sounds like a lot of work, but it really isn't. Okay, just watch your significant digits on that one. Number 8, again, it's just 2 vectors. Okay, these ones are both angled, so it'll take you a little bit longer because you got a few more x's and y's to find. Okay, that's all we're looking for there. 9 and 10 are just boat questions, and they're actually both the same kind of boat question. Okay, so there isn't one rowing across and one going across. There's only 2 of the same kind. You'll have to figure out which one. Okay, just be mindful of what it's asking for. Okay, resultant speed. Okay, asking how long it takes to row across, how far downstream. Question number 10 asks for basically the same thing, but has one little thing to make you think at the very end. Don't overthink it. It's just asking you to think a little bit, not a lot. Okay, that should cover all of it. Okay, there's really nothing on here you haven't done already a lot of times. Okay, if you have questions as we go, you can ask. I will give you somewhat cryptic, somewhat helpful answers in as much as this is supposed to tell me what you know about vectors, not what I can tell you about them. Okay, I'll still give you a hand, of course, but not as much as, I won't hold your hand. I'll give you a hand, but I won't hold your hand through it, because this one needs to tell me what you know. Okay, all right. Next. I will decide that and get back to you. Like soon, not today. I'll tell you. Not due today. I'll tell you today.
When it is due, are we going over it as a class, or are you gonna mark it, give it back to us?
No, I'll mark it,
Okay.
give it back to you, and then I'll go through it with you.
Alright.
Yeah, same as a lab. Yeah. Okay, and this one's gonna come in on paper. Okay, you're not gonna submit this one electronically to me, so show all your answers. It's a pain in the neck to have everybody take pictures and submit it through Google Classroom. Half the time I can't see what's in the picture. Okay, so just, yeah, on paper. Yes, you can. Okay.